Hi, I am a student from Harmony Science Academy, and this is Elephant Toothpaste. Elephant Toothpaste is a catalyst and decomposition reaction project in which the oxygen bubbles inside the hydrogen peroxide are removed by the reaction to the sodium iodide solution, which creates the foam substance after both are mixed. The project also includes an exothermic reaction where the solution's temperature increases. In this activity, you will mix hydrogen peroxide, sodium iodide solution, and dishwashing liquid in a tall cylinder and observe the enormous soapy foamy ropes. You will need goggles, aprons, gloves, graduated cylinder, 100 milliliter graduated cylinder, a plastic tray several inches deep, a chemical splash tray, hydrogen peroxide 30%, 20 milliliter sodium iodide solution, and 5 milliliter dishwashing liquid, as well as 10 milliliters of pink and blue food color. First, place a 100 milliliter graduated cylinder in a plastic tray that is several inches deep. Then measure out 20 milliliters of the 30% hydrogen peroxide into the 100 milliliter graduated cylinder. After that, measure out 10 milliliters of dishwashing liquid into the 10 milliliter graduated cylinder and add it to the cylinder containing the hydrogen peroxide. Add a few drops of food coloring. Observe that no reaction occurs. Now measure out 5 milliliters of sodium iodide solution using the 10 milliliter graduated cylinder. Quickly but carefully add the sodium iodide solution to the 100 milliliter graduated cylinder. Finally, step back from the work table and observe the reaction. For my ELA connection, we decided to do journals to record the process of doing this PBL. Journal Day 1, December 8th, 2018. Me and Mario met up to do the PBL tasks 1 through 3. Although we did it for a different project, we were still able to use some of the tasks that we did. Journal Day 2, February 1st, 2019. Me and Mario were assigned a new PBL, Elephant Toothpaste, and came after school to complete the experiment for the project and collect any images that we needed. Then we were told that all 12 tasks were due that day, so I had to convince the Gunesh to let me turn it in on Sunday at 11:59. This made the project a lot more stressful. Journal Day 3, February 2nd, 2019. It's the day before the due date, and I have decided to hold off the project for Sunday because it is very stressful and I don't want to think about it. I'm also doing this because I have a very bad habit of procrastinating, and I have been able to get away with it before. Journal Day 4, February 3rd, 2019. It's Sunday at 9 o'clock, and I'm just getting started. I was almost able to do the missing 10 tasks in 3 hours. Although it was very hard, it made me realize how stupid I am, and it taught me not to do this again. Journal Day 5, Wednesday, February 6, 2019. Mr. Gunesh said that the background page and the social studies connection and the ELA component each had to be 1 page long, which means we have to redo it. I asked Mario if he could do the research paper, and I told him I would do everything else. Journal Day 6, Friday, February 8th, 2019. It's Friday. Mr. Gunesh said he would put in the grades for our PBL, but I haven't turned it in yet, because I don't have the background research, and I still don't know how to upload the video. Journal Day 7, Sunday, February 8th, 2019. It's Sunday at about 1 o'clock in the morning, and Mario just sent me the background page, but I can't use it because it's no good. He just pasted the materials list and explanation of the PBL over what I originally had. Journal Day 8, Monday, February 11th, 2019. I explained the situation to Mr. Gunesh after school, and he was able to give me an extension until Wednesday. Journal Day 9, Wednesday, February 13th, 2019. Me and Mario were finally able to complete the PBL and turned it in. For our SS component, we decided to say the history of hydrogen peroxide and catalysts. The history of hydrogen peroxide. Hydrogen peroxide was first discovered in 1818 by a scientist named Louis Jacques. Although many formulas for hydrogen peroxide were suggested in the 1900s, the correct formula for hydrogen peroxide, H2O2, was first proved by Peter Melekashvili. For many years, that hydrogen peroxide was an unstable molecule. All attempts to separate it from water didn't work. It wasn't until 1894 that 100% of hydrogen peroxide was extracted from water by Richard Wallenstein, using a process called vacuum distillation. Throughout history, it was used for many things. Nowadays, hair coloring products use hydrogen peroxide. The hydrogen peroxide breaks down the hair melanin. Melanin are the grains of pigment which create natural hair colors. This product is used to bleach the hair. We need this because, as we get older, our bodies make less catalysis. This causes an increase in the concentration of hydrogen peroxide that breaks down melanin in our hair and makes our hair start to turn gray or white color. The history of catalysts. The effects of catalysts have been known since ancient times, but it wasn't until the 1800s when scientists were finally beginning to understand this sensational occurrence. Catalysts were first discovered by Jöns Jacob Berzelius, a Swedish chemist of the Stockholm Academy of Sciences, in 1836. He noticed that when certain types of substances are added to a chemical reaction, then the reaction will be sped up. Around the same time, another scientist called Doberman worked on the use of platinum as a catalyst. This helped in the invention of a lighter that was ignited by the action of hydrogen on platinum. Catalysts were used before the 1800s by Joseph Priestley, the discoverer of oxygen, and by Dutch chemist Martinus van Marum, but both disregarded the catalyst as they did not know what was happening. In fact, catalysts were in use since the time that mankind began fermenting alcohol. There are two types of catalysts: heterogeneous catalyst and homogeneous catalyst. A heterogeneous catalyst provides a surface on which the reactants become absorbed for a short period of time. The second type of catalyst, homogeneous, can be transformed at an early stage of the reaction, and it regenerates by the time of the reaction end.